Welcome to Module 16, Lesson 4. In this lesson, we're going to work on solving problems involving the multiplication of mixed numbers and of whole numbers. In this lesson, we're continuing to expand our knowledge of how to multiply a fraction by a whole number. So let's look at our first problem. Armando is a plant biologist who works on an urban indoor vertical farm. He adds 1 1/4 gallons of plant food to each of the 3 arugula trays. How much plant food does he use? Okay, this is what an urban indoor vertical farm means. It just means that they're growing inside of a room. All right, so in order to do this, we are going to use a multiplication equation. We know that there's 3 trays, and each tray needs 1 1/4 gallons. For the purpose of this problem, we're going to rewrite 1 1/4 as a fraction greater than 1. I know 1 1/4 is equal to 1 whole, which is written as 4/4, and 1/4. So my fraction greater than 1 is 5/4. So now I'm going to rewrite this multiplication equation using my fraction greater than 1. Now I'm doing 3 times 5/4. And go ahead and solve. You should have found that this was equal to 15/4. Now letter C asks us to write this product as a mixed number. I know that 15/4 is equal to 3 groups of 4/4 plus 3 more fourths, right? And why do I know that? I'm going to show you this in another way. So 15/4, I'm going to think about a multiple of 4 that's close to 15. It's really close to 12, right? So I know it's equal to 12/4 plus an additional 3. I know that 12/4 is the same as saying 3 times 4/4. If I start to think about renaming this way, I know that means there's 3 wholes plus 3 more fourths. So I know that 15/4 is made of 3 groups of 4/4, or 3 wholes, and 3/4. So how much plant food does Armando use? Armando uses 3 3/4 gallons of plant food. All right, let's go to the next problem. Number 2. Each tray of herbs at the vertical farm uses 2 3/4 packets of seeds. How many packets are needed for 6 trays? So we can rename 2 3/4 as a fraction greater than 1. So let's think about this. We have 2 3/4. How can I rename 2 with a denominator of 4? I know that this is 2 groups of 4/4. So it's going to equal 8/4 plus my additional 3/4. This will give me 11/4. So now let's go ahead and model. Write an equation to model the product of the whole number and the fraction greater than 1, and then solve. Let P represent the number of packets needed. All right, so our number of packets is equal to the 6 trays times our 11/4 needed for each tray. This gets us 66/4. 66/4 is a rather large fraction greater than 1. and we need to rename it as a mixed number. So I want you to think about this. We have 66 fourths. What we need to find is how many groups of 4 fourths plus how many remaining fourths. I see remaining and I see groups of. Here's a way we can do this. We can divide 66 by 4 because I want to find how many equal groups of 4 are in 66. When I divided 66 divided by 4, I got 16 with a remainder of 2. This 16 tells me how many groups of 4 fourths. This 2 tells me how many remaining fourths. So what it's telling me is there are 16 wholes and 2 remaining fourths. So I can rename 66 fourths as 16 wholes and 2 fourths. So how many packets are needed for 6 trays? 16 and 2 fourths packets. Go ahead and pause the video if you need any more time on this question. I want you to look at this turn and talk. How can you find the product of this problem without renaming 2 and 3 fourths as a fraction greater than 1? If we're looking at this, I want you to think, what if I broke that apart? I can use distributive property to solve when I break this apart by place value. 6 times 2 plus 6 times 3 fourths. 6 times 2 is 12 plus 6 times 3 fourths, which is equal to 18 fourths. 18 fourths, there's 4 groups of 4 plus 2 fourths remaining. I get the same answer of 16 and 2 fourths. I can also solve it on an area model. Break apart by place value. 12, 18 fourths, or 4 and 2 fourths. When I add these up, I still get my answer of 16 and 2 fourths. So how can I do it? Using distributive property. Or an area model. These sometimes are simpler to do than to go through all of these steps that we did. Because sometimes we can come up with a lot of errors when we're working with numbers this big, right? So 66 fourths is a large fraction greater than 1, and we could cause some errors just from having that large of a number that we're working with. All right, go ahead and complete the check understanding. Pause the video and press play when you're ready to check your work. All right, so for this first question, we get the cheese is 8 gallons. I went ahead and used an area model to help me solve. I broke apart 2 2/3 by place value. I multiplied 3 times my 2 ones to get 6 ones, and 3 times my 2/3 to get 6/3. 6/3 is equal to 2 wholes, so when I added together my partial products, I got 8 gallons. For number 2, I did 5 times my 3 plus 5/8. I used distributive property to solve with 5 times 3 plus 5 times 5/8, which got me 15 plus 25/8, which is equal to 15 plus 3 1/8, which gave me a total of 18 1/8. For number 3, I also used distributive property. When I solved, I got the product of 19. And number 4, I used an area model again. So I broke this apart by place value with 3 2/3. 4 times 3 was 12. 4 times 2/3 is equal to 8/3, which is equal to 2 2/3. When I add them together, I get 14 2/3.